Hi and welcome to this video about locating the roots of an equation. So we can take a harmless looking function like this one. F of x is ln x minus x over 4. Now the root of this equation is the value of x such that f of x equals 0. Namely, the value of x such that ln x minus x over 4 equals 0. Now, you probably think straight away I could apply standard algebraic techniques to this and just directly solve for x, but you can't. Imagine we add x over 4 to both sides. We'll get ln x equals x over 4, x equals e to the power of x over 4. But your standard algebraic techniques will get you nowhere. So we need to use computational methods to solve an equation like this. There is an option of using a polynomial expansion for ln x, but that's far more advanced in mathematics than where we are now. So let's have a quick look at the graph of f of x, y equals f of x. You can see there are two roots, one here and one here. In this video I'm just going to concentrate on this upper root and try and like establish some truths about this upper root. So we're looking to find the value of x such that f of x equals 0, ln x minus x over 4 equals 0. Now, let's just say we guess. So, we've seen the graph, but if we hadn't seen the graph, we might just have a guess anyway at a number like 8. So, let's consider f of 8 and just ask ourselves, does f of 8 equal 0? So we can calculate this, and we find it equals 0.07944 and so on. So 8 is not the answer to your question, where the question is what is the root of this equation, the root of f of x. It's not 8. So let's guess again. Let's guess 9 and just ask our calculator to do it again. So the calculator can work out ln 9. It can take away 2.25 and it gets the answer minus 0.05277542. So 9 isn't the answer to what is the root of this equation either. I mean, obviously, this could go on all day. We could just keep guessing numbers, see whether it equals 0, and if in this bit here, and if it doesn't, then our guess was not the answer to the root of the equation. But we can do a bit better than this. So our calculator or computer might be able to conclude this. F of 8 was bigger than 0, he says, and f of 9 was less than 0. Now the important thing for this lesson, because of the change in sign of the output, so f of 8 was bigger than 0 and f of 9 is less than 0, it must be the case that the answer we're looking for is between 8 and 9. I'll come back to that in a sec, but the robot can say, do you want me to try 8.5? And he could try 8.5, and we could just repeat this process over and over. 8.5 is not the root either, but it would allow us to close the interval which the root is in. So let's just have a look at this first bit of the expression. F of 8 is bigger than 0, f of 9 is less than 0. Because of the change in sign in the output, the answer you're looking for must be between 8 and 9. Let's look at it on the graph. So f of 8 was more than 0. F of 9 is less than 0. So that means that our root, this number here, this x value, must be somewhere between 8 and 9. It's like the easiest logic problem ever. F of 8 was more than 0. F of 9 is less than 0. The root must be somewhere in between. So since there's a change in sign of f of 8 and f of 9, one's positive, one's negative, we can conclude there's a root in between. So this approach works in general, but we do need to be a little bit careful with it. Consider this example. Let's say f of x equals 2 over 2x minus 17. I won't do all the robot animations again, but f of 8 equals minus 2, f of 9 equals plus 2. So there's a change in sign in the output. One of them's negative, one of them's positive. So what can we conclude? Our root is between 8 and 9. No, we can't. Let's look at the graph. So f of 8 is minus 2, f of 9 is plus 2, but it doesn't automatically follow that the graph cuts the axes in between these points. In this case, it clearly doesn't, because there's an asymptote at 8.5. So in order for this approach to work, we need to make sure that f of x is continuous. If it's not continuous, this approach won't work. So now I've just got two further questions for you to think about, which I'm not going to give the answer to. Feel free to ask. But we need to be precise, as always in maths. So if fx is continuous and f of 8 is greater than 0 and f of 9 is less than 0, can the robot conclude there is exactly one root between 8 and 9? If f of x is continuous and f of 8 is greater than 0 and f of 9 is greater than 0, can the robot conclude there are no roots between 8 and 9? So pause this video, have a think about whether these two statements are true, and I'm not going to reveal the answer on the next slide. I'm just going to show you two graphs that should lead you to the answer. So two statements there, they're precisely written. Are they true? Here's a couple of graphs. They should answer for you whether those two earlier statement questions are true or false. Or the answer is yes or no. So, like I say, feel free to ask any questions. But if you've understood the video, these questions, in combination with these graphs, you should be able to answer the questions easily.